Okay, so we're going to do inequalities today. Actually, this is the beginning of this course. I kind of front-loaded it a little, and the reason is because I want to be able to go back to things. But also, it's possible that we'll get ahead of it a little, which is good.
Yeah, like last time.
Yeah, because if we get ahead of it this time, then people might want to just go ahead and take that test, because you never know what's going to happen, and it might be good just to get that over with. All right, so I got to go back and share this. And I'm sorry, but I don't want to share my video, I don't think. It's got this thing right on top of that. I don't know if I'm sharing that, so I got to go back and, oh, there it is. It's there, so I think I am sharing it. Okay. All right, so we're going to talk about inequalities today. So first things first, here are the symbols. So the greater than symbol. So I always say, if you're reading from left to right, you come to the larger gap side first, so it's greater than. The one underneath that, if you're reading from left to right, you come to the little teeny point first, so that's the less than. And if it's just a greater than or a less than with no equal to, half of an equal to underneath of it, no line underneath, then we use on the number line what we call an open circle. It's not shaded in or colored in. And these symbols are new. This is a parenthesis and a parenthesis, and I'll explain that later. And MyLabs Plus sometimes uses those symbols, which I don't care for because I don't like these. I like the circles. Because these sometimes, if you're sloppy, look like an arrow. And an arrow means something different. Okay, so then greater than or equals to has the line underneath, and that gets colored in or shaded in. And we call that a closed circle. And that it would be a bracket for MyLabs Plus. And then less than or equal to would be less than or less than sign with a half of an equal to sign or a line underneath. Again, closed circle and bracket. So those are our symbols. And that's what we're going to do today. So this really is good because first we're going to just do the answer and show you how to graph it. But then we are going to start from inequalities, which are really the same thing as an equation. So it's a good review of how to do an equation too, because you really have to be fluent with solving an equation, a linear equation, before you enter into your next math class. So first we're going to do x is greater than 3. And notice the one beside it is greater than or equal to. So then we'll just see what the difference is. Okay, so x is greater than. Now I'm just going to number my number line as much as I have to. I'm not going to go all the way to 10 or anything. To be honest, MyLabs Plus usually numbers it for you, so you really don't have to worry about that. Now, because it doesn't have the line underneath, we use an open circle, so it's not shaded in. And greater than means we're going to the right. The number's larger than 3. And also notice that my arrow on my number line is facing the same direction as the greater than symbol. That is only true if x is first. X is greater than 3. If it's the other way around, you have to flip that. But notice when I put x to the right, to the left, sorry, x is greater than 3, then my arrow looks like it is a greater than sign. That, a little sloppy. Okay, and then if, and it's just above the 3. And if it says greater than or equal to, then I simply do the same thing, but this time I shade it in so that it's called a closed circle. but pointing the same direction. So that arrow means to the right, that goes all the way up to infinity. So it means that these numbers go from 3 to infinity. And we put those in parentheses. That is called our domain. Our domain is from 3 to infinity. That's how we write that in what's called interval notation. Sometimes you'll be asked to write this in interval notation. So let me write that, interval. There's two different types of notation. This one is interval notation. And then see, this one says it does not equal 3 and it does not equal infinity. We always say that nothing ever equals infinity or negative infinity. It gets really close, but it never equals it. So in order to say that it equals 3, like this one, closed circle means it can be 3 or anything above, then we use the bracket like I showed in the beginning slide. And we put 3, infinity, but we put still the parenthesis on the right because we say it doesn't equal infinity. So the difference between these is that the first one is saying 3 to infinity is our interval, because all the numbers between 3 and infinity, not including 3, not including infinity. The one on the right says it goes from 3 to infinity, including 3. So just another point, just to make sure you understand this. When I say something is greater than 3, like this one on the right, for instance, it does not start at 4, because there are actually an infinite number of numbers in between 3 and 4. There's 3.0000001, 3.0000011, and you get the point. There's infinite numbers of numbers between 3 and 4. And so this is saying it's not 3, but it's starting just a fractional point, fractional amount above 3, just like right above 3. So then let's do, actually I didn't do the second notation. That's interval notation. Let's do set builder notation. And so I'll do it in a different color so you can see. It's the set of all x's. If x is your variable, if your variable's y, you put y. And then you put such that, which is just a straight line, x is greater than 3. Okay, so that is called set builder notation. So two different types of notation you're going to be asked to do and recognize. Notice with set builder, the initial solution here, x is greater than 3, is a part of that. And all we did is put those squiggly lines in front of it and behind it, and then x, and then a line. So it's just that initial at the tail end of it. And then over here for this one, it would be the set of all x's such that x is greater than or equal to 3. Let me draw that first one a little bit better so you can see what I'm doing. And that is a key on your keyboard above the bracket. Beside the P, you can see those set builder symbols. And then my labs might also offer those, but it's on your keyboard if it doesn't. Okay, I'm going to have to erase some of what I just did so that we can keep everything straight here. But I do want to make that notation again. 3 to infinity, set of all x's such that x is greater than 3. And the second one is 3 to infinity, infinity symbol, but it is a bracket, and that's the set of all x's such that x is greater than or equal to 3. All right, so now we just have less than. So on a number line, no equal to sign for this one. so we just have our open circle, and because the sign is going to the left, we go to the left. And on the other side, same thing, only because it's less than or equal to, our circle is closed or colored in. So notice this arrow, it keeps going and going and going to the left. That's going to eventually go to negative infinity, not to positive infinity. As it goes 0, -1, -2, and so on and so forth, all the way to negative infinity. So where it stops is 3. Our interval notation, we always begin with the smaller number, so we do negative infinity to 3. So notice how that changes from the top one, when we had a greater than symbol. And then this one over here would be negative infinity, still parenthesis because it never equals negative infinity, but it does equal 3, so on the right side we have a bracket. And then again, the set builder notation is just the set of all x's such that, and plop in the solution that we had. And we're done. So that one's kind of easy once you get your solution. Forgot the beginning part. Like that. Now, MyLabs Plus, usually when it asks you to do this, sometimes it'll give you the parentheses. Sometimes it'll give you those brackets. So make sure that if you don't write it twice or it'll say you're wrong. Okay, so now I think I got everything. Let me go to this bottom one, which is a little bit unique. The bottom one, notice it has two things going on here. So it's saying that -2 is less than x. -2 is less than x. And it's saying that x is less than or equal to 3. And another way of saying that -2 is less than x is to say that x is greater than -2. So notice that same idea. If I say -2 is less than x, that's the same as saying x is greater than -2. So if I'm drawing this on a number line, we start with -3 and see if I can go up to 4 so that I'm a little bit on both sides of it. Okay, so greater than -2 would mean I'm going numbers this way. And less than 3 means I'm going numbers this way. So when it says I'm there, I'm in between the two. And the 3, less than or equal to 3 means that one is included, so I color that one in. So again, the set builder notation is the easier one. And it just means I put the set of all x's such that in front of it, and then the set bracket, and I'm done. And then interval notation is really not difficult either, because notice you're going from -2 to 3. -2 to 3. You don't equal -2, so you have a parenthesis. You do equal 3, so you have a bracket. All right, now let me backtrack because I didn't show you the other way of drawing this on a number line. The way that I said I didn't care for, but sometimes MyLabs Plus uses it and sometimes they don't. So let me just go back to number 1 and show you what I mean. If you're saying that x is greater than 3, and I said you put a circle because it's not equal to 3, but sometimes they'll put that parenthesis and then the arrow. Okay, so like that parenthesis that you would put for your for your interval notation, they put that parenthesis sometimes instead of an arrow, instead of a circle. And then over here, if it's greater than or equal to, then they would put a bracket. instead of a closed circle. Again, I don't like that, and if I were writing sloppy, which this one right here kind of shows what I'm talking about, that almost looks like an arrow. It looks like I'm saying it goes in both directions. That's why I don't care for those symbols. If you're using a typewriter, though, and the way MyLabs Plus does, it's not sloppy, so I guess it's okay. But you do need to understand what that means. So that parenthesis means the same thing as a circle that's not shaded in. Like that. These two are the same thing. And then this one over here means the same thing as a circle that is shaded in. And then just so you realize if it goes the other way, let me do these just so that you see what it looks like if it goes the other way. Then the parenthesis, I'm just going to put the 3 there. The parenthesis is facing the other way, like that. So up here, the parenthesis is like the first parenthesis you would put if you were putting something in parentheses. Down here, it's like the second one. And the same with the bracket. If it's this one right here, it's a bracket going the other way. So just be aware of what those mean. In real life, you wouldn't have to use them. You could use the circles, which you're probably used to because that's something you probably saw in high school. I'm just going to do a few that are a little unusual. So I want to do some negatives to remind us how to count on a number line. So this says x is greater than -3. I'm not sure why my typewriter wanted to change that to a really fancy looking greater than symbol, but I want to remind you that -3, -2, this is how you set up a negative number line. Sometimes people want to put them in the other order, -1, -2, -3, instead of -3, -2, -1. So I want to remind you of that. And then it's the same thing. Other than that, it's the same thing. We would have a circle that is not shaded in because it's not equal to -3. And just as that inequality sign is pointing to the right, my arrow points to the right. So what I'm saying by that is this symbol is going that way, and my arrow, notice, is the same. That will change down here because notice the X is on the wrong side. So let me go ahead and do that one. So all of these X's to the left, that's the traditional way to write it. But if it's not, if it's on the right, you would be wise to simply switch it because it's easier to understand. So notice when I switch my 2 and my X, I have to flip that sign too, because if I say 2 is less than X, that means X is greater than 2. So that just helps you to know that it is going to the right. That symbol means it's going to the right. Up here, you may have made a mistake. So understand that flipping. Now I'll backtrack to this one that has a fraction. If you have a fraction, you need to understand where that fraction is on a number line. It might be helpful to change it into a mixed number or a decimal. So I'm just going to change it into a decimal. X is less than or equal to -2.5. You may know that. You may have known that one. Or you can use your calculator. And the reason that's easier is because now I know that I have to include a little bit, that I'm going to be right in between -3 and -2. My X is going to be in between them. That's what that is. It's in between -2 and -3. So it's right here in between them. And I'm going to the left. I'm going smaller because X is less than or equal to that. So fractions, go ahead and convert them to decimals for the purpose of graphing so that you know about where they are. And also, again, we have that negative situation. -2.5, I was doing -2.5. Say I was doing X is less than or equal to -2.5. I mean positive 2.5, sorry. Then I would also be in between 2 and 3, but notice that's to the right of 2, and here it's to the left of 2. So just, I guess I'm trying to point out, be really careful when you're looking at negatives, because they tend to, sometimes we forget how they work. So just be careful with them. Take a couple extra seconds to make sure you're right and that what you're saying makes sense. All right, and then the bottom one was, again, the same type of situation we had before. But I do want to remind you that, once again, negatives is what throws people off. It goes in this order. A lot of times people, especially when it's just negative numbers, they want to start with -1 and go to the right to -6, but it's the opposite. And so when we have it written like this, it means we're in between -5 and -3. This one is including -3. So it gets closed circle. And again, our notation, -5, comma, -3, bracket. Let me go ahead and do set builder notation and interval notation for all of these. The first one, it goes from -3 up, so it goes to infinity. Sometimes it's better to graph it. Even if it doesn't ask for it to be graphed, you may want to graph it first. It's not equal to either of these, so I put parentheses. That symbol, like that infinity symbol, is this. For some reason, this pen is not working super well today, the stylus, and it's not drawing it very well. And then the set builder notation, the set of all x's such that, plop in my solution, and I'm done. Next one, we know we're going from -infinity, never equals -infinity, so that's just a parenthesis, comma, -5/2, and you could put -2.5, and then bracket, because it equals that, can equal that. And then again, set builder notation, the set of all x's such that x is less than or equal to -5/2. By the way, I was going over some of the tests to see if there was any like mistakes that I could see that were just notation mistakes that maybe you could get partial credit for. And not in this class because we hadn't done this yet, but in my online class, there was one that said more like x is greater than, or not x, they used y instead of x. And the only thing the person did wrong is they wrote x instead of y. So just be careful with that. And if you keep getting something wrong on My Labs Plus, look at that, because I know it can be frustrating to get something wrong over and over. The next one, just again, remember it's x is greater than 2. We flip imagine the whole thing pivoting in a circle. So that means that we're going from 2 to infinity for our interval notation. For our set builder notation, it's the set of all x's such that x is greater than 2. And that's the way we should always write it, with x on the left when we do that. This last one, the set builder notation is the set of all x's such that, and then we just write that whole thing, -5 less than x less than or equal to -3. And again, it's not picking up my brackets very well either. All right, just some more. Only these, notice, aren't solutions. This is the entire problem, and now I have to find the solution. So I'm going to add 5. I'm going to, first of all, what you do is you treat it like an equal to sign at first. The only difference is, and this is the only rule you have to remember that is different from how you solve an equation. If you multiply or divide by a negative number, by a negative number, not into a negative number, but by a negative number, then you have to flip the inequality sign. In other words, if it was less than, you make it greater than. If it was greater than, you make it less than. That is the only additional rule. So really, other than that, you simply treat it as if it were an equation. So like I said at the beginning of this, it's like it's giving us time to practice equation solving, because that is a very important skill in algebra, at least. Okay, so I'm going to put my line down at my inequality sign, and the first thing I'm going to do is rearrange the equation, putting anything that is a number by itself on the right and all my variable terms on the left. And if I have to switch sides, I switch signs. So I have 2x, and then I bring the 5 over here and make it a -5 or -5. And I bring down that -3. That just will not let me make that 5 correctly. At that point, I don't have to worry about that rule. So that's a good thing about it. The distributive property, and when I go to rearrange, I don't have to worry about that rule. Once I'm done that, I have to worry about the rule. Okay, well, actually, I can combine like terms also. I can combine those terms, still don't have to worry about the rule. At this point, that's when I have to multiply or divide by what's in front of the x or underneath of it. And so I'm going to divide out the 2, and it's a +2. Okay, so it doesn't matter that the 8 was negative, the 2 was positive, and that's what I'm dividing by, a positive number. So I don't do anything with that symbol, nothing. It's only when I'm dividing by a negative number, not into a negative number. So that's just x is greater than -4. So let's just do all the different things we have to do with this sometimes. We have to make a number line. And so it's an open circle to the right, or a parenthesis. We have interval notation. It starts at -4 and goes to infinity. And again, that's easier to see from the number line. If you're having trouble figuring out if it's greater than -4, which does it go to infinity or does it start at negative infinity? You might want to look at the number line. You can clearly see it's going to the right, which is positive infinity. And then we have the set of all x's such that, and then we put this solution here. X is greater than -4. So we have to put the solution in there, not the original problem, the solution. Okay, I'll keep that on that side and then go to the next one. I'll do it on the left and then I'll erase everything. Okay, so this one right here, I'm going to do it on the left side. So again, first step is simply to put whatever is not an x term on the right and whatever is an x term on the left. Right now I'm just rewriting it. So this right here has to move to the other side and it becomes plus. So I have 1/2 x is less than or equal to +3/2 minus 5/2, or I could have put negative 5/2 plus 3/2. It doesn't matter what order you put those two numbers as long as you remember this one stays on the same sign, so it has a minus in front of it. This one switch sides, so it changes from a minus to a positive or to a plus, depending on if you put it before or after that. Now let me combine those. So I have a common denominator, so it's 3 minus 5, which is -2. And -2 over 2 is -1. So now what I have is 1/2 x is less than or equal to -1. So that procedure did not require me to listen to the rule. The only time I have to do the rule is now. And so I can either divide both sides by 1/2 or I could multiply by 2 over 1. Either way, I am multiplying or dividing by a positive number, so my inequality sign stays the same. That's a negative times a positive. That's a times symbol there, not a negative sign. And it looks like a negative. I had to make it real big. So that makes that -2. X is less than or equal to -2. And I will write the notation up here. So that means the number line it is including -2, so it's a closed circle, colored in, and goes to the left. That means it's going to -infinity. So my interval notation is -infinity, comma, -2. It can equal -2, so I have a bracket there. And my set builder notation is the set of all x's such that x is less than or equal to -2. So far I haven't had to use that rule at all, but this next one I will. So I'm going to erase everything, so I'll make sure you get that down. Okay, so this next one I'm actually going to do twice. So 2 minus 3x is less than x plus 4. So I'm going to get all my x terms on the left. So I have -3x minus x, because this one had to travel to the other side, so it becomes a negative or a minus. This 2 is positive 2. You always look in front to see what sign. So when it goes to this side, it has to become -2. Okay, so now I have -3x minus x, and that's a 1x. So it's -3 minus 1, which is -4. So now in this case, notice I am going to be dividing by a negative sign, by a negative number, which means my inequality sign goes the opposite direction. It's -1/2. 2 over 4 reduces to 1/2, and it's a positive divided by a negative, so it's -1/2. I wrote that kind of sloppy. Let me just rewrite that. Okay. So -1/2 is in between -1 and -2, or -2 and -1. So we're going to write a circle above in between those two, going to the right. And that means it is -1/2 to infinity. Or let me put my brackets around my solution with the line. The set of all x is such that x is greater than -1/2. I said I was going to do that one twice. And because I know that some of you do not like to variable terms necessary to the left, just do what's convenient. So I'm going to do it that way and just show you how it looks. Okay, so if instead I bring the -2x to the right, making it x plus 3x, and I bring that 4 to the left, making it minus, so it's 2 minus 4 on this side, and x plus 3x. So I just switched the sign I'm bringing things to, which like I said, I noticed that some of you on the test did that. So that would be -1/2 is less than x. And remember we said that if your x is on the right, this is a perfectly okay answer. And if it were a paper and pencil test, I would say you're right. But it makes it hard to interpret it as far as doing it on the number line. So it's better to switch it, but then you have to switch everything. So you have, like I always say, pretend like there's a fulcrum or something right under that, a fulcrum like in physics where everything else is like dangling in the air and it's just a circular motion around the other way. That kind of turns your sign so it becomes a greater than sign. I don't know if that helps. Whatever you need to do to remember that. Remember that if you're going to switch sides at this point, you need to switch your signs. Okay, and I just have one more to do. So the point I'm trying to make there, obviously, is that no matter which way I did it, I got the right answers, but I had to remember that last step. Okay, so the last one, this one, the difference between this one and the second one is that that's a -5 halves x. So I'm going to go ahead and bring that to the left side and make it a positive. And then I'll bring the -3/2 to the right side and make it a positive because it was a negative. Combine my like terms, so I have 6 over 2x less than or equal to 3/2. That's 3x is less than or equal to 3/2. I do want to point this out. When you're doing this and you're dividing by 3, easy way to do that is just to put it on the bottom of that fraction because that's dividing. Because now what you have is 2 times 3, bottom, the denominator times 3. That's 3 over 6, which is 1/2. So that is x is less than or equal to 1/2. That is a positive. And notice again, I didn't have to worry about flipping my inequality because everything's positive. All right, I just want to, these are just a little bit harder. I don't know if I gave you guys a chance to do any. Yeah, after this slide, I guess I'll make some up for you guys to do to make sure you know how to do it. So these are just harder than the other ones. Again, gives us a nice opportunity to go over how to solve an equation because as you can see, it's the same idea except for that one rule. We don't even have to worry about that rule until the very end. Okay, so first thing we do whenever we have parentheses in an equation, the first thing we want to do is distribute the number outside of the parentheses. It's multiplied to the parentheses in order to get rid of it. So we're multiplying both the x and the 5, so we get 2x plus 10 is greater than -3x. And then we want to rearrange this so that we have our x terms on the left. Draw my line. I like to do that because I think it helps people figure out what goes where. I notice sometimes people want to do opposite operation when things are on the same side, and this kind of helps you not do that. So that becomes a plus 3x, and that becomes a -10 on the other side. And so that's 5x is greater than -10. We're dividing by a positive 5, so we're not flipping our inequality symbol. It's only when we're dividing by, not into. Okay, so let's go over the different things we have to know. Let me go ahead and use the parenthesis this time. So this would look like this, a parenthesis and then an arrow to the right. If MyLab was using a parenthesis rather than an open circle. Same thing though if I had done the open circle and to the right. They mean the same thing. And then we have interval notation, so it starts at -2 and it's going to positive infinity, and it is not touching either of those. Or we can have set builder, the set of all x's, such that x is greater than -2. And when you get to your next math class, they will probably, if it's math 150, And then if you have to take statistics also, and that's such that, or sometimes it's called given that, that symbol becomes very important in those classes as well. So practice kind of saying it. The set of all x is such that x is greater than or equal to -2. All right, let's go to the next one. All right, now we're looking at this one, and as you see, we have two distributive instances, but I made one of them a negative just to remind us about how to do that. So 3 times the quantity of x plus 5 is greater than -2 times the quantity of x minus 3. So we distribute that 3. So remember, it's 3 times everything that's in there, every term that's in there. And then when we distribute the -2, that's a minus right there. That's a minus sign. So it's -2 times positive x, which is -2x. But when we do -2 times -3, that becomes a positive because it's negative times a negative. That's +6. Don't forget that. A couple of people did that wrong on the test. Okay, so that gives us, when we switch it, 3x plus 2x is greater than -15 plus 6. That's 5x is greater than -9. And now I'm going to divide by a positive number. So x is still greater than -9/5. Because I don't want to flip it because it's a positive 5. And it's helpful to know that that is 1 and 0.4. No, 1.8. 4 if this is 8. So that means it's in between 1 and 2. Make that one 0, 1, 2, 3. But it is significantly closer to 2, so my circle should be much closer to 2 than it is to 1. And that's not a closed circle, that's an open circle. So I'm going from 1.8 to infinity. Where I can say, also you could have put, oh, wait a minute, I'm sorry, that's a negative. I dropped my negative sign when I rewrote it. Let me redo that number line and everything. So this is actually, I'm glad I caught that because -1.8 is closer to -2, so be careful there when you do that. It's going to be closer to -2 right there, and it's a open circle, and it's going to go to the right still, all the way to infinity. So you can put either one of these numbers. I'll put the -1.8 to infinity. And that means the set of all x's such that x is greater than, and again, I can put -1.8 or I can put -9/5. Of distribution. So I think I'll just do it underneath of it since I have enough room there. Okay, so first I'm distributing this 2 into that set of parentheses. So that's 2x plus 6. And then I'm distributing a +3 into the other set. So +3 times x is +3x. +3 times -5 is -15 or -15. Greater than symbol. -3 times x is -3x. -3 times -2 is +6, so that becomes a +6. And then I had +4x at the end. If I just rearrange it, I don't have to worry about the negatives. I don't have to worry about flipping the inequality. Right now I'm just rearranging. 2x and 3x are good to go on the left. This minus 3x becomes a plus 3x and moves to the left. And the plus 4x is a minus 4x and moves to the right. I mean, it moves to the left also, sorry. And then we need to get the numbers to the right, the numbers that are by themselves. So positive 6 becomes a negative 6 because it's switching sides. Minus 15 becomes plus 15 because it's switching sides. But this 6 up here just comes down like it is. Combine our like terms. So on the left, we have 2 plus 3 minus 4, which is 4. Positive 4. On the right, we have negative 6 plus 15 plus 6, which is 15. Dividing by a positive, so we keep our inequality the same. And that gives us x is greater than 15 over 4. But for context, it's good to change that because we're putting it on a number line. We have x is greater than 3 3/4, or you can put 0.75. Because 4 goes into 15 3 times. 3 times 4 is 12. So we have a remainder of 3. That's how we get the 3 3/4, remember. 4 goes into 15 3 times with a remainder of 3. And we put that back over 4. And that is 3.75. If you want to write it that way. So on a number line, start with 2, 3, 4, 5, and it does not equal 3.75. 3.75 is very close to 4, closer to 4 than it is to 3. So that is supposed to look like it's to the right of the middle. I guess I'll do it again just to make sure you see that. Okay, and then that means that we're going from 3.75 to infinity. Which is the set of all x's such that x is greater than 3.75. Be sure to listen to MyLabs Plus if it asks for a decimal, a fraction. If it says an integer, you should write it like this. Integer or mixed number would be this one. It's not a decimal. Well, I wouldn't say integer because integers are whole numbers. So if it says fraction or mixed number, you have to do it like this top one or this one. If it says you could do a decimal, pay attention to where it says to round it. So let me give you guys a couple that are going to have somewhere the sides switch and some where they don't. So graph them and write them in those notations.
What would 2/3 of the decimal be?
0.6 repeating. That one repeats, so you should probably just keep it as a fraction. I'll go ahead and put them up here, and then you can compare them. So on number 2, I got a whole number. Did you?
Yeah.
Okay. The one there that is a little tricky is when you get negative x is less than or equal to 9. Remember, you have to divide by a -1 to get rid of the negative.
So when you divide by negative, you switch it.
You're flipping the inequality on the last one. Yep.
So it's only when the one on the x is negative?
Exactly.
Okay.
So I want to repeat that. She said that it's only when the number multiplied or divided to x is negative. It's a good way to remember that. If that number with x is negative, or x is negative, because negative x means -1 times x. That's the only time you're flipping your sign.
That's what messed me up on the second one, is I flipped it on accident.
Okay. So the last thing I want to look at actually is just a couple of word phrases, and that's just very quickly introduced in this section. I'm going to actually insert another slide here, because I want to review some things that we've learned about word phrases. Like when we have more than, so far it's meant to add. When we have less than, it's meant to subtract. And when we have is, it means equal to. So a couple of phrases that are kind of a combination of these. If we have is more than, it means a greater than symbol. So if that word is before the more than, so that's the difference. Is before more than. It's a greater than symbol. And likewise, if we have is less than, it no longer means subtract, it means a less than inequality symbol. So having kind of combining the word is with these two changes it. You have to be aware of that when we're doing word phrases. So let's look at a couple. I'll give you a second to finish copying that down. We have plenty of time, really. Okay, so 6 more than would mean 6 plus because it does not have the word is. And then twice a number, so 2 times a number, we'll just put X for the number. And now notice the second part says is less than, so now it's the inequality symbol. Very, very subtle difference, notice. So we have to really be vigilant when we're looking. If the word is before the more than or less than statement, it changed what it meant. It no longer meant subtract 14, it meant an inequality symbol. So now we have to solve this. We're going to keep the 2x over here and bring this 6 over here and make it negative, which gives us 8. 2x is less than 8. And when we divide by 2, which is positive, we have x is less than 4. And so looking at that on a number line, we put a circle on the 4, or an open circle, and point to the left because we're looking at less than. It means we're going all the way down to negative infinity and stopping just before 4. Or we can say the set of all x's such that x is less than 4. And the next one is 3 times a number, so that's 3x, is more than, again, that's a greater than symbol, not a plus symbol, 9. So this one's a lot easier. All I do is divide both sides by a positive 3, get x is greater than 3. So set builder, I'm just going to do it here and put the set of all x's in front of our solution. And that means it's going from 3 to positive infinity. Or on a number line going from 3, well, not quite 3, but 3 to infinity, like that. So just really, that's what you have to pay attention to if that word is in front of those phrases. And that's going to be it for today.